Okay, so building platform services using Kubernetes. So this chapter is like just a synopsis of this chapter is discusses like Kubernetes extensibility, focusing on extension points like plugin and webhooks. And here it elaborates on the operator pattern, emphasizing Kubernetes controllers and the role of custom resources and what tools used for operator development, like KubeBuilder and operator framework. So yeah, as I said, a lot of like this chapter built on previous chapter, understanding architecture of Kubernetes, and how everything works, how we can extend the capability of Kubernetes and integrate with and automate some of the things. So here, what is the platform services? Those components that are being extended in Kubernetes. Here, I don't know, I highlighted a lot of things. So yeah, there's a lot of like things that, for example, was hard for me to understand. So I hope our discussion will help us to uncover some of these things, how they work and how they interact with Kubernetes, and how does it benefit development here. So this was like the kind of the short synopsis of it, and some of the things that Kubernetes uses in that we see it's being used in Kubernetes ecosystems, how the plugins are being extended, and how Kubernetes is built. Because like Kubernetes was built with this in mind of interoperability, it's a like very extensible system, and it provides a lot of capabilities to extend on already existing things, and also provide also that the capabilities that are provided is a part of the ecosystem. So yeah, I just for Kubernetes, I'm sorry, I want to show this meme because that's how I feel like usually people say start with Kubernetes. That's very I think describes Kubernetes very well, because I don't know, I think I had it ready, but I like it very much. I don't know if you've seen this one. That's when you think Kubernetes is just a YAML file, and you have so many things. So that's what's like Kubernetes system is. So okay, plugin. So all the Kubernetes is built on top of plugin and extensibility, like all of the things that we are using in our system. Namespace like networking, CNI plugins that we talked about, storage, extensibility, container runtime, and all the other devices that are being used as a part of Kubernetes is actually pluggable by different vendors that you can use and interchangeably. I don't know. Does it make sense so far?
Yeah, it is. So maybe I think this is really good, but I think we could kind of build. We can talk about a bit on why platform, right? Why basically I think this has been covered in the chapter first or second, right? That why platforms, right? And why it is becoming so kind of interesting to kind of build these platforms, and why Kubernetes is right for that, right? So, hmm.
I'm sorry. What is the question? I didn't.
It's not a question. I think we can just quickly talk about maybe why Kubernetes for building platforms, right? So I think that
Building what?
the
Platforms.
platforms, right?
Platforms.
Platforms.
Platforms. Okay. Sorry, my audio is not good. Okay. So for building platforms, yeah, I think this is very also kind of in trend of right now of building Kubernetes platforms, where people build like custom platforms on top of it, and they can use this extensibility, whether they need like some kind of integrate with some in-house systems, or they need to provide some capabilities, additional capabilities. They always can't. It's pluggable in Kubernetes. They can use extend the API on top of APIs, and bring it into the environment. Like for example, yeah, operator framework that allow us to do that, to bring those capabilities to the platform.
Yeah, I think this modular nature kind of makes it really popular, right? Kubernetes, because it kind of extends the same principles that it follows internally for its own resources. And you can basically adopt that. So, for instance, like defining, a schema for your object and writing a controller for it, and making sure that the reconciliation happens the same way that would happen for a pod or a deployment, can happen for any custom resource that you can, imagine. So virtually it makes it possible to build anything on top of Kubernetes. And obviously, as authors of Kubernetes, they decided not to do everything because it's very easy with software to do a lot of stuff, and try to automate everything. But then it's the Unix philosophy where do one thing, do it right, and make it modular, right? And that is the approach that Kubernetes is built, on top of. So yeah, I guess that makes it really popular, and I guess people also call Kubernetes the operating system of the cloud these days. So yeah. Nipendra, would you like to share your experiences around, why Kubernetes is such a popular tool and how it makes it, really easy for building platform services on top of it?
Yeah, I think we already kind of touched upon that point already. Um, uh, but as the main thing is this API thing, right? API, having the common API irrespective of the cloud you are in, right? Or maybe on-prem, on cloud, and if the API call works a similar way irrespective of the environment you are in, it makes the right choice to build things on top of it. That's that I would say, and that's why I think if you kind of go back to the first chapter, there they have compared OpenShift and some other of the tools there to which the platform which were built on top of Kubernetes, right? And
Mhm.
then all of them, what we are seeing right now, what other people are building, it is on top of it only, right? So yeah.
Yeah, that's the reason. Like it, you say it makes popular that it's already has some things out of the box and a lot of things you can extend upon, and add to the environment. But it takes it takes a great yeah, expertise, I think, to build all of the things out. And this is what chapter will be touching on, the operator SDK and a Cube Builder. That's something that I think we had a session with Carlos a little bit, how to develop like custom automations for your Kubernetes to do things and extend on everything. So a lot of those things, so like over here, they just cover in a very briefly, since this was very covered extensively in other chapters, how it works. Like for example, OpenID, how we can add OpenID to the Kubernetes, or use a default Kubernetes system role-based access control, and in that chapter, how's this admission controller goes through, which steps is go through over here in Kubernetes, what mechanisms are in place, for example, uh, to perform any operations in the in the cluster. And this is kind of here it talks about like how this can be extensible and how it can be used for building on top of this your own automation and functionality. And particularly you can do that with a operator framework. That's how you extend the on the Kubernetes APIs. So it says here that that's API server. It's an operator that interacts with the client Kubernetes, and from from what I've so far kind of got interacted with the operator, is that the way you can generate boilerplate code and everything that it needs to develop this integration with Kubernetes. So some of the patterns that are used that is here is discussed is okay, Kubernetes resource and develop controllers to reconcile them with a with a state to define in them. So they use the CRDs to create the type of APIs. The first, like for example, before we want to create some kind of resource in the Kubernetes, we create this CRDs that define the type of APIs. This is commonly you can see used to, for example, if you need to install like additional things into a cluster, like Nginx controller, where you need to install CRDs for that purpose. And I think if I don't, correct me if I'm wrong, that's kind of the this is how they built. This is also kind of like a type of operator they build on top of this Kubernetes SDKs to extend the functionality and to integrate Nginx with Kubernetes and provide that ingress custom resource for path trafficking.
Anybody have used any operators earlier?
So yeah,
If
like I was discussing with Lodimir, right? So Prometheus is one common operator that almost every cluster kind of has installed. Earlier, there were help charts and manifests that we had to kind of configure and make do with. But with the Prometheus operator, I think things have become pretty straightforward to get that installed in your cluster. I've
yeah,
also used operators for other stateful databases. Uh, yeah, go on. Go on.
yeah, the operators are very common. More, I would say, in the OpenShift. So when I was using OpenShift in my time at IBM, a lot of installation was done through the operators because they have this UI kind of looks like this UI where you go and you pick the operator and you install it in your OpenShift on your OpenShift platform. And like for example, I don't know if you want to, we can do maybe quick demo. I can install this just to show the working of this operator and what's the benefit of it installing them. Installing instead of just, for example, having the plain installation. Oops, it's already exist. Yeah, already. I think I tried it, but I deleted. Let me see if it's. That's strange. Okay, maybe I'm not going to be able to do that because I tried to do something, and it says already exist, but I can the namespace doesn't. Okay, maybe then the next time I'll try to, or we can install some other operator. Is there any other operator we can install that you can think of besides the Prometheus?
What error did you get there?
The way I just want to see the way it gets installed. Something I broke. Okay, it got installed.
I think we can't see other screen, right?
Yeah, we can't see your terminal. We
Oh,
just
you can't see the screen. Oh no.
Yeah.
Okay, I thought. Okay, why is that? Okay, so I'm
So there's a
sorry.
question in between. What is the difference between operator and controller? Uh, you want to take that? Or
So operator, well, from my understanding, is just it's like a whole package. You can package whole application that leverages controller in Kubernetes to control, right? I don't know, to leverages controller to automate deployments or application or any automation inside the Kubernetes cluster.
okay, so I'll just try to maybe put my thoughts there. So if you look at operator is nothing but controller plus some additional knowledge about the operation knowledge about the given tool. So for example, controller may be just kind of deploying the MySQL there. But let's say if your MySQL is 70% full, you would want to trigger additional storage, right? Now for that purpose, we have another layer on operator. So operator has the operations knowledge as well on top of controllers, and that is how they differ. Hope you answered the question, Safiddin.
so is it right to say that all operators are controllers, but all controllers are not operators?
Yeah, you can say that in a way, yes.
Mhm.
That's what at least I can think
Okay.
of. You can say like that.
Hi there. I have a question about the business case that presented Nip Brandt. Sorry if I don't know if I'm saying the name correctly. Is just the business case that you mentioned here, Francisco Perez. Sorry, I did introduce myself. If you want to control the space in a MySQL, it wouldn't be better to do it with a kind of daemon sets container rather than using an operator, or what is the difference between of them? I'm I'm asking that because I'm very new on this, so maybe I'm asking something dummy. So
No, that's fine. That's fine. Yeah, would you like to take that, Vladimir?
so
So his
my
question
question
is,
is,
if you want to configure MySQL,
yeah.
would you rather use daemon sets instead of operators?
Well,
Is
to
that correct?
control the MySQL, for instance, if
To
you have
control the
issues,
MySQL.
yeah, or to
Yeah.
monitor MySQL, for instance, is the business case that presented Nipendran about to control the space of MySQL. So I
Mhm.
was wondering if it's better to do it with a daemon set with all the tools that you needed rather than use an operator. That's my question.
Yeah. Okay, so I'll start. Maybe others can add their inputs as well. So in case of MySQL, I think it won't be a daemon set, but rather a stateful set. Because if you go with a daemon set, it will create one pod on every node of your cluster. And typically with stateful applications, especially like MySQL,
Okay,
unless you are going with a multi-write setup, right? You would want only one pod to handle the writes and other
yeah,
pods to manage the reads.
you're right.
So you would want to go with a stateful set. And operator is something that will help you manage the operations of those stateful sets, right?
Okay,
You can very well go ahead without using any operator and directly write the entire stateful set YAML. And then once you have deployed your MySQL using stateful sets, there might be cases where you would have to manually go and do some operations as a human, right? Run some kubectl commands, take some backups,
yeah, yeah,
set the MySQL in read-only mode, kind of, set it back to read-write mode, create a read replica. All these are operations that a human operator would go and perform on those stateful sets. Using an operator, you can automate these operations that a human would do, and that is one of the primary reasons or goals of operators. It is to reduce the human toil involved in managing software. So you have to go with stateful set, and operators can automate whatever you do with the stateful sets, or even deployments or pods or any resource on your cluster.
hmm
So
okay,
like the way question had right now, I mean daemon sets and stateful sets. So for example, um, not everyone would be aware of these differences, right? And And when you kind of go and put these things in production, we don't want these kind of mistakes to happen, because deploying something as daemon set rather than a stateful set would result into kind of a say not a good outcome there, right? So what does these controllers or these operators are built for? That anybody can go ahead and deploy. So for example, like the way Valdemar was showing that, right? On the OpenShift, you have this catalog, right? So you are an OpenShift operator and you want to deploy MySQL. So you go to this catalog and then you just click a button, and then something happens behind the scene. Now, what's happening behind the scene is something which is optimized by the professionals in a way, and then it is deployed on your cluster or environment there. So that is the whole idea about having this operators framework, where the right set of configurations are being deployed on the given environment. And then, of course, it's good to always good to know what's happening behind the scene. So, um, but the idea is simple, that I am doing the best approach what has been given by the people who have built the software. So, for example, MySQL team or whomsoever publishing the MySQL operator, right? They would have configured in the right approach, right? I just kind of click up and deploy it, and I'll not be in a situation where I do something obvious wrong. It's not going to be that situation to be in.
Okay, thanks. Thanks for clarifying. Thank you.
Right.
Okay, so just to continue, so to create operators or custom resources in the Kubernetes, we need to define this API, and we use for that CRDs to install the things that we want to, that are not common, that don't exist in already with the schema of Kubernetes. And here we can do that by installing some of the CRDs. And for example, I just wanted to show you how like a CRD would look like. We can get the CRDs, and like any CRD that is
I think,
installed here.
Voldemar, sorry to interrupt in between, but
Yeah.
I think if you can just tell a bit about what is a CRD and why we need it before you demo it, it would be helpful.
Okay. Yes, CRD is needed for schema declaration of API. And so before you want to install it, for example, before you create, like we have a pod, it has a defined schema. It's API version, and it's a default. Like for example, maybe I need to show this. If I have a pod here, like if we have a pod, it
Sorry to interrupt. Can you increase the font, please? Really sorry. We really can't see what's happening.
oh yeah, okay, try.
Yeah, it is better. Yeah.
So this is kind of the manifest, and this is needs to be, for example, defined by the API schema. And what the CRD do, I don't know, what is it so long, I guess. What does the CRD does is it declares that schema to be used in Kubernetes cluster. So first, before like installing any custom resources, we need to define this with a CRD, and then that is kind of it's a schema open API schema specification with different text. I think they have a over here example. Maybe here it will be better. The definitions, for example, the way we're gonna create this type, and over here we define all of that. This is the
Voldemar,
this is the
Voldemar,
yeah.
sorry to interrupt you. But I think what would make much more interactive here is if you can talk about the why we need CRDs. So I'll just quickly brief on that maybe. So what happens is when Kubernetes you install, right, you get some basic set of objects like pods, deep deployment, daemon sets, and so on. But then what happens is, let's say your company want to have some custom built on top of it. So the example can be, for example, let's say you want to deploy or you want to create an object, right? Let's say cars, right? For example, there can be an object called cars, for example, right? Now, what can happen is, so this is a custom object which my company is interested to build, right? Like in this case, I think the example was given for some web app, right? Now, I don't have that car or the web app object on every cluster in the world who installs Kubernetes, right? So I would get the base Kubernetes setup, and then I want to install my custom object. So when I say kubectl install cars.yml, for example, it creates an object called cars in my cluster, and then which I can manage with the help of kubectl. The same thing is, so that is done with the help of CRDs. So CRDs are custom resource definitions using which we can extend Kubernetes for custom objects. Now, I think, Valdemar, can you go to that YML file and actually explain? I think it would be much more clear. Yeah, now you can, I think, take it forward. Yeah.
Yeah, so here this will define this what Nipandra talked about, like custom resource that we want to create and be recognized inside the cluster, and it uses this schema to define all the fields and how what is needed to be for Kubernetes cluster to understand this resource. And yeah, so this is a part of I would say part of extensibility of Kubernetes, where we can define our own types and be able to install them in the cluster. So you would you use this the same way with an operator or with other like installation that you bring into the cluster, like we already talked about, Nginx Ingress controller, cert manager. All of them are use this CRD to define the types that they need to for resources that they need to install and operate inside the cluster. So is anyone like maybe can pitch in, like have they used this, have they had to do any type of installation that use the CRDs, or had any experience with the with this type of installation inside a cluster? Okay.
Yeah, definitely. I have used it for some of the cases, and it is a very common patterns or common things to be done. Like for example, Istio, right? Istio, at least when I used it, right? I think it's still the same, right? So when you install Istio, or when you just have a base Kubernetes cluster, right? You don't have an object like, for example, virtual service, right, or destination rule. Those things are not there, or talk about Cilium or whatever, right? So before you install those, you don't have objects like virtual service or destination rule, which are talking about in terms of Istio, right? Now they come in only when we install a given software, that Istio, right? Now, what happens as you install Istio, it would create this object of virtual service, for example. And along with that, it is also going to install a controller. So there are two parts when you install these CRDs. One part is creating the objects, and second part is installing the controller as well. So let's say when I create this kubectl create web app, for example. Now, this is an object, like pod is an object, deployment is an object, right? Now, what happens once you send the query or when you send the YML to deploy a deployment object? There's a controller which runs in the Kubernetes cluster, continuously watching, saying that if I get a request of deployment um, object creation, I would do something, right? So with the CRD, we want to install, of course, the object, what we want to have, like cars, web app, or whatever. Along with that, we will deploy the controller, and controller is continuously watching that for the new object. So that happens with the help of HCD watch. So, or a key value watch, whatever. Then typically we use HCD as a watch there, right? So what happens is when we create an object, so the way it happens is as an API server makes a request, kubectl apply pod.yaml, whatever it is, right? That request I'm sending to the API server, and now that is basically sent to a, think about a while loop, right? Something is running continuously, and now as soon as that particular request has come in saying I want to create a pod, so control is nothing but controller in general is something which is running a while loop for you, and those while loops are especially looking for a given object type, and as it finds an object it performs something. So controllers are something which is running continuously on a system, and then when we deploy an object or a CID object of a given type, it would then create the respective thing. Like for example, when I say I want to deploy a daemon set object, now daemon set is the object I'm creating, but daemon set eventually creates one pod on every node. So that's a controller job to kind of do it. So similarly, when we deploy a controller of MySQL, it would create MySQL master slave and so on different nodes. Hope it makes sense.
Yes, it does.
Yeah, so
One more common example of to explain this is like the cross-plane project, right? So I'll just share a link on chat here. Yeah. So can you open this link? Okay. I've shared in chat.
yep, just opening right now.
Yeah. So if you see the YAML here, right? Alongside config maps and field export, there's a kind bucket as well at the top, right? So what this would do is this would create a bucket in AWS S3 bucket. Now this is possible because you might have installed a CRD, which kind of listens for this kind of API object to be created. Once you run kubectl apply, it will see that, okay, fine, I need to create something called a bucket. And then your controller will have the logic to, parse this object, validate this, go to AWS, create a bucket, and then respond with whatever the status is, right? So you can extend your Kubernetes using CRDs and make it do more than what it does, right? So there's a standard set of libraries, a standard set of objects like deployments, config map, secrets, stateful sets, which come built in with your cluster, built in with your Kubernetes. And then there are these other extensions that you can add on to your cluster, right? And build a platform around it. So yeah, I mean, I find this example really helpful to explain CRDs. And in a similar way, you can add MySQL, right? There could be a kind MySQL, there could be a kind Prometheus, there could be a kind Aerospy, anything under the sun.
Is this also installed as an operator, or it's the control plane? I mean this not the control plane. What I'm talking about, the cross plane.
Yeah, cross plane. There's an operator for cross plane as well, I guess.
Yes, interesting.
Not sure if they have it hosted here.
Ah, okay.
Yeah.
Oh, okay. This is AWS controllers. Oh, this was the part of a cross plane, or this is part of AWS?
I think this is a separate part. This was to explain the CRD concept. Yeah, so it's a custom resource, right? It's not inbuilt. It does not come inbuilt with your Kubernetes. It's a CRD, which allows you to do this, to create a bucket using Kube APIs.
Mm-hmm. Okay.
I can find an example with crossplane as well. If you just search for crossplane S3 bucket example, I think that should throw something.
This one.
Let me check. I'm sharing a link.
Okay.
Yeah. So if you scroll down, yeah, scroll down, scroll down.
Provisioner config.
Yeah, so this blog basically covers how to install and configure crossplay, but then there's a bucket example as well. Yeah, this is the bucket
Over
example.
here.
Yeah.
So this.
So Crossplane is a pretty popular project, and people have also started kind of replacing Terraform with Crossplane, right? So essentially, you no longer need to kind of depend on Terraform or CloudFormation. You can have everything, including your infrastructure, managed inside your Kubernetes itself, right? So if you want to create EC2 instances, if you want to create node pools, if you want to create buckets, whatever you want to create in the cloud, you can codify them as YAMLs and let your Kube API handle it.
And they define this everything through the CRDs, right?
Yes, yes.
Yeah, so that's the good use case of the, I like how CRDs are used.
Yes.
Okay. Yeah, I'll take a look at the crossplane. Okay, so the operator use cases. So the main purpose of operators in the cluster is to, as we already talked about it, and was described the use case with database, where you want something to watch over your resource and reconcile the state, as they say, right, and manage that resource inside the cluster. So by installing the Kubernetes operator, it's built on top of operator SDK, as I understand, and it use that extensibility to mechanism, as we talked about it, to watch over the resource loop over and reconcile the state, make sure it's according to the declaration state, and if any operation needs to perform, the operator will do that. And so the operator, like, using categories of platform utilities, as they say here, general purpose workloads and app specification. I used install as an app operator, as installing apps, like, for example, Cloud Packs. This is very kind of very workload intensive applications for ML, where we had to install this Cloud Pack. It even has its own schedulers and stuff like that to manage the state of application inside the cluster, to do all of the updates and to do, yes. So you don't have to manually watch this. Here they talk about some of the examples of with the Prometheus Cert Manager and the Rook. I haven't used that one. Haven't seen this one, Rook Storage Operator. But this is the most common one, is an operator, Prometheus operator and Cert Manager operator that kind of take that ease of operating this inside of the Kubernetes cluster. So and here for general, what else here? For operator, they talk about here the use case where, for example, if you want to automate your cluster resource creation, and you create the operator for that. For example, if you need to create a namespace with resource quotas and the user everything, so you don't have to, the person doesn't have to go automatically to do that. You can create this type of, develop this type of operator inside your organization, where you create, somebody's creating namespace, and it's already creates with a provided quota and the user that can access that namespace. That will be kind of like in the, as I understand, in the platform utilities. So have anyone had to like developed any of the platform utilities or any kind of automations with operator SDK of that sort of the like that takes on the operation, things like for example, automating some of the work in the cluster that is common.
No, not really. I mean, I've been wanting to get into this operator thing, but there hasn't been a solid use case where we had to kind of build an operator from scratch. In most cases, like we use community operators and they are sufficient. We have built like small POC operators, but nothing fancy.
Yeah, so there's a, like, if anybody wants to try, there's a good this tutorial where he does the memcache operator, develops memcache operator from, yeah, it's operator SDK using, and it will create all the boilerplate stuff, and it'll tell you what API, how it's structured, how it creates the CIDs to go over. And yeah, this is like a simple hello world step by step that something can be done and to understand, but it's in a Go language. I think operator SDK has many languages that you can use, but there's another one, KubeBuilder, that is only written in Go. So I've just played around with this one a little bit, try to create a boilerplate and use this code snippets to create and deploy an operator. And I think there's a video session of Carlos doing KubeBuilder, using KubeBuilder and creating a job operator. There was like 3 videos, I think 2 or 3 sessions of that. And there's also a good resource to take a look how this type of operators can be developed for general purpose, like for example, creating some job that automates some kind of mundane task in your cluster to on a day-to-day operations, and that's where it's commonly used. So app-specific operators are the ones that we talked about, the database operators that we would install, and you can find all of those. Like I think, yeah, for example, MongoDB, you can find any of them in here, and just go in and install this. I think I tried to install MongoDB. It requires license or some kind of key, but there's other ones that you can install and just look what is get installed like and how it operates. So as I say, it reduces the human toil in deployment and day 2 management of this kind of work, like especially when deployed widely, is updated frequently. So the database will be good use case, since it has maybe you can automate a lot of like backups and other things that involve managing a database. So developing operator. I don't know if I don't know if you want to try this. I mean, we can try this example to do this, or you want to try on your own just to install this and create a boilerplate and see what goes into building the operator, and how this framework can be leveraged and what APIs can be used for that. It does require the good knowledge of Go language, just to navigate around this. And to understand what you're doing also requires good knowledge of Kubernetes, of all of the mechanisms to to tap into as you're extending and automating on top of it. So I don't know, do you want to take maybe install like for demo, for sake of demo, just try to see if we can install the operator, or should maybe for the next time should leave this have this for the next time, have this walk through the creation of a operator with the operator SDK framework.
I'm not sure whether how many people are Go developers here, but if you can just show us, maybe not this time, but next time, maybe just like a very high level thing that, okay, this is a source code. If we compile it, something happens and so forth, right? That would suffice, I
Mm-hmm.
believe. So I don't know whether to go in the code, because I'm not, at least I'm not a Go expert here. But if you just want to show it like once, like, I mean, if you have tried again, right? There's not compulsion that you have to do it, but if you can basically see that this is a Go code, I'll do this thing, it will get installed and so forth, right? That will suffice. Yeah.
Okay, so maybe because for time it'll take a little bit time involved. So maybe for next time I'll prepare this like a generating boilerplate code and just going through this creation of resources and what it does, and how it does it in terms of creating all the stuff, necessary stuff. It's a very simple thing to do. I did this one a little bit, played around with this one, as I said, so I can do that one
Sounds
for
good.
the next time. So anybody else wants to add? Maybe, I don't know if we should continue with this. That's a cube builder. Cube builder, as I said, you can watch. It's also another type of like SDK, I guess, or framework to build to build the operators, but it's only written in Go. Whereas operator is SDKs have multiple languages, and the meta controller.
Yeah, I think we can take it in the next
It's,
session if it's okay.
yeah, let's take it. Yeah, let's take it on the next session. I don't know if so. I'll prepare this part where I can install the operator and just go through a little bit of through the code.
Sounds good.
There's also a popular framework that supports Python. I think it's called KOPF, Kubernetes Operator Pythonic Framework. And if more people are familiar with Python,
Which one?
it's called KOPF, Kubernetes Operator Python Framework.
This is the one that you shared.
So that's basically a simple operator that we had built uh, using KOPF. I'll share the link of the framework as well. So this is the one.
Oh, so that's another framework for operator deployment, specifically
Yes.
for Python. Okay. Is this also adapted like by a community, or because I haven't heard of this one?
It is actively maintained.
5 years ago. Okay, interesting. Yeah, maybe Python will be easier. Okay, so any since maybe we'll continue with the operator SDK installation next time. Is anybody else has anything that we can discuss in the meantime? We have 5 minutes left.
I think we are good. We can close today early. Um, Anybody has any other suggestions or any other feedback or points to be taken into account? Okay, sounds good. Then we'll see you guys next week.
Yep. Thanks.
Okay.
Thanks a lot for the session today, Lodimir.
Thank you
And
very much.
yeah, see you guys next